Hello guys, today I am going to discuss chapter number 3 matrices from standard 12. In today's lecture I am going to discuss the definition of matrix and some types of matrices. Let's get started. So very first, the definition. Matrix is an ordered rectangular array of numbers or functions. The numbers or the functions are called the elements or the entries of the matrix. Next definition is order of matrix. A matrix having m rows and n columns is called the matrix of order m cross n. It looks like this way. So you can see this is the wait a minute. Okay, so this is the first row, row 1. This is second row, n onwards. This is mth row, so rm. These are called columns. So this is first column, I can write C1. This is column number 2. This is column number 3, I can write C3, and this is column number n. So this matrix have m rows, first row, second row, third row, and this is mth row. So m rows and n columns, first column, second column, and third column. So this matrix is of order m cross n. Let's move onwards. So these aij's are the entries. A11 means first row, first column. So I stands for row and J stands for column. So if I write A23, so it means this element, second row and column number 3. So second row is first row and this is second row. Column number 3 means first column, second column, and this is third column. So this will be my element. Let's move on. Example. So you can see this matrix X. Matrices are always denoted by capital A, capital B, or capital C, or capital X, Y, and Z, some constant numbers. So this matrix X has, you can see, two rows, first row this, and this is second row, and so this is 2 and 4 columns. This is column number 1, column number 2, column number 3, and this is column number 4. So this is 2 by 4 matrix. Next, this is another matrix Y. You can see that there are 6 elements in this matrix. There are 3 rows. This is first row, second row, third row, and there are 2 columns, first column and second column. So 3 rows and 2 columns. So this matrix is of order 3 by 2. Matrix can be 1 by 2 or 1 by 3 order. We can define the matrix of order 1 by 2 or 1 by 3 and so on. Let's move on. Let's discuss now types of matrices. The very first definition is column matrix. What it says, a matrix is said to be a column matrix if it has only one column. Let's have some example. Now in this first one, you can see it has total 3 rows and 1 column, single column, and 3 rows, first row, second row, and third row. In another one, there is only 1 column and there are 4 rows, first row, second row, third row, and fourth row. First row has 0 element, second row has element number 13, third row has the element pi, and fourth row has element -7. Let's move on to the another definition. The another one is called the row matrix. What it says, a matrix is said to be a row matrix if it has only one row. Now you can see that this matrix has a single row and there are 3 columns, first column, second column, and third column. So order of this matrix will be 3 by 1, as I said in the previous slide. move on to the next example. Now you can see there is a single row and two columns, minus 7, 7. So order of this matrix will be two rows, sorry, one row, sorry, this will be one row and three columns. This will be one row and two columns. Let's move on. Next definition is square matrix. What it says, matrix in which the number of rows are equal to the number of columns is called square matrix. In previous two definition we saw the rectangular matrix, means number of rows and number of columns were not equal. In such case, where number of rows and columns are equal, we call that matrix as a square matrix. There is another definition. If a matrix is m cross n, then if m is equal to n, means number of rows equal to number of columns, then we can say that it is a square matrix and its order will be n, small n. Let's see the example. Now this matrix A has, you can see three rows, first row, second row and third row, and three columns, first, second and third. So this matrix is of order 3. It can be 2 by 2, it can be 1 by 1, it can be 4 by 4. In that case, the order will be number of rows or number of columns. Let's move to the another definition. It is of diagonal matrix. What it says, a square matrix B of order m cross n. Make sure definition start with the square matrix. So we can define diagonal matrix only for square matrix. So a square matrix B of order m by n is said to be a diagonal matrix if all of its non-diagonal elements are 0. Right? Let's have the example. You can see that first observe that matrix B non-diagonal elements means this is diagonal. So non-diagonal elements, you can see this is 0, this is also 0, correct, are 0. In C, in matrix C, this is diagonal, have the element non-zero, and all other elements, you can see that all other elements are 0. These 3 and this 3. So this matrix is called a diagonal matrix. So now you can see in matrix A, it is a diagonal matrix. Right? Let's move to the another definition. It says scalar matrix. Let's see what it says. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Again, make sure that this matrix, this definition starts with the diagonal matrix. So in diagonal matrix, if all the elements in a diagonal are same, then it is called scalar matrix. Let's have the example. Now again, I took the same the examples. You can see the diagonal elements in B, minus 2 and 2 are same. In C, diagonal elements of the diagonal are same, 7, 7, 7, and all other elements are 0. So it is a diagonal matrix as well as a scalar matrix because the entries on diagonal are same. Let's go to the another definition called identity matrix. Again, a square matrix in which elements in diagonal are 1 and all other elements are 0 is called an identity matrix. Make sure this definition is only for square matrix. I'm going to round it, that word. So for rectangular matrix, we cannot find the identity matrix. It is only for square matrix. So the entries on the diagonal are 1 and all other entries are 0. You can see that in these examples. In matrix B, this is 1, elements on diagonals are 1 and other elements are 0. Again in C, elements on the diagonal are 1, 1, 1 and all other elements are 0. Same way in matrix A. So in notation, the second part of the definition, this is right in terms of notation, right? Let's move on to the next definition called zero matrix. A matrix is said to be a zero matrix or null matrix, zero or null matrix, if all its elements are zero. Simply all the entries in the matrices are zero. You can see in the examples, in matrix A, matrix B and matrix C, all the elements are zero. So it is called zero matrix. Let's move to the next one, equality of matrix. Now equality of matrices. This definition is for two matrices, matrix A and matrix B. If all the elements, they are called equal matrices if they are of the same order and each element of A is equal to the corresponding element of B. Let's have the examples. You can see in matrix A and B, -3, -3, 1, 1, -2. Sorry, there is a correction. It should be -2. It must be -2, and this is 7. So these two matrices are same. Even you can see that it is a 2 by 2 matrix and it is a 2 by 2 matrix. Means A and B both are 2 by 2 matrices. So they are called equal elements. Okay. Thank you and Jai Hind.